Hello friends. Last time we had seen in our first and second lectures that how diode is manufactured and how transistor works and how transistor is manufactured and all that related to amplification and all that. Now in this third video lecture we shall see chapter 3 of 11th standard bifocal electronics. Now, to understand the topics explained in this lecture, you will require to have my notes of 11th standard bifocal electronics named as semiconductor devices and circuits. If you do not have these notes, then you can visit our website and purchase the notes of 11th standard bifocal electronics. Complete study material you can purchase on our website www.vidyasagar.academy. Now starting with the third chapter, it is study of components. In this chapter we shall study classification of components, simply active and passive types of components, then the resistor, its color codes and different types of resistors. Then we have to study the capacitors, their types, and series and parallel combination of capacitors. Then we shall see the inductors and briefly understand the basic idea regarding transformers. We have already seen about transformer in our first lecture related to half wave rectifier, full wave rectifier and bridge rectifier topics. Then we shall have a brief idea about different types of switches. While referring these notes, while watching this video, you will require to refer some of the topics in my notes. So keep those notes with you while watching this video. Now starting with topic 3.1, classification of components. Basically there are two types of classifications of components: active components and passive components. Active means which have the ability to amplify, rectify and do such types of processes. For example, diode, transistor, MOSFET, etc. are very good examples of active components. Then passive components do not perform active functions while working in the circuit. For example, resistor, capacitor, inductor, etc. So broadly they are classified under only these two categories, active and passive components. Now this first topic of components, it is 3.2, what is resistor, that we shall start with. Resistor is a passive element or component used in almost all types of electronics and electrical circuits. The main highlights of the resistor can be it is mainly used to reduce electric current in any closed circuit. It is used to produce a voltage drop across it, and then it is also used to produce heat in some applications. You might have seen one example regarding this in goodnight tabs are available, and those tabs are heated up by a resistive element beneath that tablet. So this can be one of the applications of resistor to produce heat. Its unit is ohm, and the derived units are kilo ohm, mega ohm, and this is the symbol of resistor. We shall understand the color codes of resistor. This topic will be important to you in practical related applications also, because in 11th standard you have to perform practical experiments on this topic. So here is the symbol of resistor. There are 4 color rings printed on the body of a resistor. One image is also given at the bottom on the screen. Now you can see on the left hand side there are 3 color rings equally spaced together. The left one is first band, then the green shown is the second band and the third one is multiplier band, and keeping some distance there is one more band or color ring, it is known as tolerance band. Now these four color rings, with these four color rings we can evaluate the exact resistance value or the resistance of a particular resistor. How it is to be done, that we shall see on the next screen. Now we shall see how color codes can be used to evaluate the value of a resistor. We know on the body of the resistor, cylindrical body, color rings are printed on body of every resistor. So using those color rings we can evaluate the resistor value. For example, suppose we are given with one color combination, say brown, black, brown. Now to evaluate the value of this resistor, we shall use the chart given on page number 40. Refer that chart. In that chart you will see that the brown on the first band position has a value of 1. Then black at the second band position has a value of 0, and brown at the third position, that is on the multiplier position band, it has a value of 10 raised to power 1. So the value of this resistor brown, black, brown will be 100 ohm. The value will be directly in ohm. Taking another combination, red, red, orange. Refer the chart again. Red stands for 2, red stands for 2, so it becomes 22. Now orange multiplier value will be 10 raised to power 3. So the value of this resistor will be 22,000 ohm, that is 22 kilo ohm. Again taking one example, yellow, violet, green. So in this, yellow stands for 4, violet stands for 7, and green has a multiplier of 10 raised to power 5. So the value of this resistor will be 4.7 mega ohm. Here the value will be actually 47 followed by 5 zeros. So we divide it by 1000 to convert it into kilo ohm, and again divide it by 1000 to convert it into mega ohm. Now the fourth band given on the body of the resistor is known as tolerance band. That tolerance band can be used to find out the manufacturing error that might be present in the resistor. For example, suppose we take this resistor 100 ohm. Now suppose on this resistor the fourth color ring is golden. In that case its tolerance means the error present, the manufacturing error present will be plus minus 5%. So the value of this resistor may be from 95 ohm to 105 ohm. So that will be the range of the resistor. So every manufacturer gives the tolerance value. So they give you the idea that this resistor might have this much error. So for this resistor having a golden band at the fourth position, the value may be from 95 ohm to 105 ohm. So such resistors have 5% error. So they can be used in our general purpose applications. Now for the types of resistor, there are basically 3 types given in our syllabus. The first one is carbon composition resistor. They are made up of grounded carbon with some binding material, and they are generally cylindrical in shape. They have 2 terminals of copper. The copper is tinned to avoid corrosion. They have color rings printed on their cylindrical body to show the resistance value, and for that, to evaluate the resistance value, remember the color code chart we just have seen. Now the types of resistor continued further. Wire wound resistor. It is a rather different type of resistor and it is used for power applications, for high current and high power application purpose. It is made up of nichrome or manganese or such resistive wire which is wound on cylindrical former like ceramic or china clay. And its value, the resistor value of wire wound resistor may range from 0.01 ohm to 100 kilo ohm at a very high power consumption, 5 watt to 200 watt rating. The third one is metal film resistor. This resistor was introduced some years back by Philips, and it is metal film resistor is very accurate, and it has got less manufacturing errors. It is very similar to carbon resistor except for the less errors. It has got quite low errors and high accuracy. Metal film is used in as a resistive element here. The outer part of this resistor is coated with epoxy to avoid any type of electrical contact within the circuit connected in a complicated circuit or in a very thick or crowded type of circuit. It will not have any contact with its body. They have very high precision and accurate resistors with quite less errors. Now there are two more types generally known as variable resistors. They are of two types. Preset resistors means which can be set only occasionally, not regularly, and the other one is a potentiometer. The left one shown is a preset which is to be adjusted using a small screwdriver or aligner, and the right one, green, is known as potentiometer. Both are used to change the resistance within a fixed range. Coming to topic 3.6, we shall see now what is capacitor. Capacitor is actually an electrical device. It is a passive type of electrical component. It is used to store electrical energy in the form of potential difference across its two terminals. Now the internal structure of a typical capacitor is given below. Here you can see there are two metal plates, parallel metal plates, and in between these two plates there is one dielectric medium, that is one kind of insulator, just like paper or ceramic, mica or whatever like that. This dielectric sheet is sandwiched between two metallic plates, and so the distance between these two plates, metal plates, will be equal to the thickness of the dielectric sheet sandwiched between the two plates. Now if you refer to the topic of capacitor in our notes on page number 43, you will see that one formula is given. C is equal to Q upon V, and the most important formula here is C is proportional to A upon D, where A is the area of these two metal plates and D is the distance between the two plates. Now here the distance will be equal to the thickness of dielectric medium used or sandwiched between the two metal plates. So as thin as possible the dielectric medium is used so that the distance between the two plates should be as minimum as possible, due to which the capacity of the capacitor will increase. So C, which is the capacity of capacitor, is proportional to A upon D. Increasing the area of the capacitor is not practically feasible. It is not suggested to increase the area of the plates rather than decreasing the distance between the two plates, because if you go on increasing the area, the physical size of the capacitor will be very large. So generally it is a routine practice to use a very thin dielectric medium between the two metal plates. Now the classification of capacitors is given in this chart. You have to recall and properly prepare this classification, because it will be definitely asked in your 11th standard college examination. The capacitor is classified into three main types: electrolytic, non-electrolytic, and variable capacitors, and they are further subclassified into different types. Now the types of capacitor, there are basically three types of capacitor. Electrolytic polar capacitor, it has a thin oxide film as dielectric material. All these simple points you have to just remember and write them down in your 11th standard internal examination, because these theoretical points have nothing to do actually with our 12th standard syllabus. And so if you just go on reading the topics and the important points as given in this video, it will be enough to prepare for the 11th standard internal college examination. Again, another types of capacitors are given. Other types here: aluminum capacitor, tantalum capacitor, then mica, paper, ceramic and polyester capacitors are shown. Sometimes there may be the demand in 11th standard examination to draw the diagram of a paper capacitor. So I have shown here the internal structure diagram of a paper capacitor. Now the combination of capacitor, just like as you already studied in 10th standard, that how to connect the resistors in parallel and in series and what are their effective resistance values. Just like that, there can be the combination of capacitors in series as well as in parallel. Now, so far as the resistor combinations are concerned, the capacitor combinations are exactly opposite with respect to resistors. If you connect a number of capacitors in series, then the total effective capacitance will be equal to 1 upon C equal to 1 upon C1 plus 1 upon C2, 1 upon C3, like that. And if number of capacitors are connected in parallel, then the total effective capacitance will be equal to C1 plus C2 plus C3, that all the capacitances will add together. Coming to the last but one topic of this chapter, what is inductor? Inductor is also a passive element or device. It is commercially known as coil, and it has the very important property of inductance. Inductor is mainly used in transformers and generators and coils for producing different high frequency oscillations in electronic circuits or communication electronic circuits in particular. Now it is defined as, inductance is defined as the ability of a conductor to induce voltage when current changes its value through it. Whenever the current is flowing, particularly alternating current is flowing through an inductor, then the magnetic field surrounded on the inductor will have the changes taking place, because the alternating current flowing through the coil or inductor will constantly change. So the magnetic field around that coil or inductor will also change. So due to that, proportional electric voltage will be induced in the coil itself. So inductance is mathematically given here as L. It is denoted by L. L is equal to mu 0 dot mu r multiplied by n square multiplied by A upon L. The values and the relevant meanings of these terms are given on the right hand side. Mu 0 is the permeability of free space. Mu r is the relative permeability. N is the number of turns of the inductor or coil. A is the area in meter square, particularly the area of the core, and L is the length of the complete conductor which is forming the coil itself. Now there are different types of inductors available in the market. Air core inductor shown on the top right corner. Then iron core conductor shown at the bottom right corner. The ferrite core conductor, it is shown on the left bottom corner, and there are many more such inductors available. Now the types of capacitor, there are basically three types of capacitor. Electrolytic polar capacitor, it has a thin oxide film as dielectric material. All these simple points you have to just remember and write them down in your 11th standard internal examination, because these theoretical points have nothing to do actually with our 12th standard syllabus. And so if you just go on reading the topics and the important points as given in this video, it will be enough to prepare for the 11th standard internal college examination. Now we suggest you to do routine practical experiments in electronics in your college. This will help you understand the working of different components, because this chapter doesn't contain any numerical problems and something like that. So just concentrate on the basic working of different components. So that can only be possible if you attend to the regular practicals which are conducted in your college. So I strongly suggest you, because being a teacher of electronics and physics, I will definitely suggest every student to uh, remain present for routine practicals in your college. And I will suggest you one more thing: if your college doesn't have that much facility available to conduct experiments, then you can suggest your college teachers, to ask for our experimental kits available on our website. Also, if you do not have the material of 11th standard bifocal electronics, then you can purchase that study material at our website www.vidyasagar.academy. So thank you friends. While studying, if you have any kind of difficulty whatever, then you are welcome to contact me through my website only. The link is given www.vidyasagar.academy/contact. All the best. Thank you.